got a vote for 33? 32.75? Love it.
27. Oh, good.
So let's crunch it out. Let's crunch it out once manually just to refresh our mind. This is probably the only y-intercept you'll calculate in this class by hand, but I want you to understand the mathematics behind it, because the math that we're going to be doing in this calculation is something we'll be doing over and over in here. So in order to find the y-intercept, we've got to find what b is. You already know what m is, so you know, we're over here, y equals mx plus b. Okay, so m's 9/8. I'm going to drop the units for a second.
Oh,
What are y and x?
Oh.
Yeah, exactly. Now we're like, oh yeah, I got this now.
Okay.
So Tara, which one do you want to use?
10 and 44.
10 and 44. Love it. So 10 is your x. So that's going to run this guy over here. 44 is your y. That's going to be this guy over here. And you're looking for that guy right there. And then it's just a matter, this is, again, equation boot camp. That's the whole point of equation boot camp, was to kind of look at equations like this. So you're going to end up, this is going to be 44. I'm going to change this to a decimal because I deal better with decimals. It's okay with you guys.
Isn't that 11.25?
It is. It's 11.25. Thank you, Tara, for using 10, because I knew that was 1.125. So exactly right, 11.25 plus b. Subtract this guy over, and if I do my math right, I get a 0.75. And then I got to borrow, so 3 minus 2 is 2, and then I have to borrow again. Yep, 32.75. With me so far?
Yes.
32.75, which means I now have a model of my equation. I know the slope is 9/8, and I know the y-intercept is 32.75. What's the interpretation of what that 32.75 means? What does that 32.75 mean? Say that again, Tara. Nice and loud.
When it first starts and we're time is 0.
What you have decided is time 0. It's the y value where time is 0. So what have you decided time 0 is here? Do you remember? What is 2? Oh, you can't see. Sorry. 2 doesn't mean 2. It means, say it nice and loud, 2 years after 1990. So when you see year 0, this really is not 0, but 1990. So an interpretation of what that is, actually, you tell me. Interpretation of what that means, 32.75. Thank you, Aaron. In 1990, there were approximately 32.75 million people. Uninsured, thank you, uninsured. Assuming that the pattern continued backwards in time. Remember, our first data point was 1992. We're making the assumption that it actually can be extrapolated out 2 years before that. So in other words, you can kind of, if you draw this line down, you can kind of see where it would cross.
So,
Go ahead.
So I was thinking just by looking at it, if it had crossed across that way, we would have been able to see that what that.
You could have gotten a ballpark of where it was, yes.
That's where I got
You could totally have gotten a ballpark. Now you got to remember that line I drew wasn't perfect.
Right.
It wasn't perfect. It was ish okay, but fair enough. So now we have a model. The model we're going to have, based off of this form up here, is going to be y equals 9/8 x plus 32.75. Why do you want a model? Why don't you want an equation to talk about the data?
What is it?
Francis, go ahead.
I used the other point though.
That's okay. You get the same results, don't you?
Well, maybe I didn't enough right.
It's possible. Assuming you do the exact correct math, it doesn't matter what point you use. It has to be true for both of them.
Oh.
Yeah, so you would have plugged in 2 here
Yeah.
and 35 here. And the math wouldn't have been as nice. I couldn't do it in my head then. But at the same time, you could totally knock it out.
I got y equals.
Oh, actually, 2. It would
Y
be.
number 8 plus or minus 1.
Say that again.
I got.
This would have been 35.
Yeah.
This would be 2.25.
Yeah.
35 minus 2.25.
2.25.
Right. 2 times 9/8.
Oh.
Don't forget you have to use this x value.
Oh, right.
Right, yes, it's quite nice. I see you watched the quiz solution video from last week. Hey, it's very nice.
You're making fun of you.
What? No, you did not watch the quiz solution video, I see. Yes, please, Brittany.
Now, if we have the formula, we could go and check 2015 and
Ex-
see what amount of people would
Nice.
contribute.
So now that you have a relationship, you've got a very, very powerful tool. you can now take that equation, and here's why I say it's very powerful. It's also very easily misused. You've got a model, an equation that governs those 5 data points. You can carefully use that model to then predict into the future what things are going to happen, yes? Now the key word, there's 2 key words in that statement I just made. One was 2 letters, if. The other one was carefully. The reason Bend went through the economic collapse it did in 2009 was people doing stuff like this incorrectly. Holy crap! I bought a house in 1980. It's 1990. It doubled in value. It's 2000. It doubled in value again. By 2010, it's going to double in value again. Or maybe lose all its value. Because the behavior that you're seeing over these 8 years might or might not continue. So the big if is if the data continues to behave as it's been behaving, you now have a predictor formula. Which means you can now say, suppose 20 years. Suppose 20 years from 1990, aka 2010. How many uninsured people would there be in 20 years? In 20 years. If this, you could find out, couldn't you? You could find out by simply taking x, changing it to 20, and simplifying this expression and figuring out what y is. But I don't want to do that right now. Not right now. I want to get to that point eventually, because we've done a great deal of awesome work. And we've put an awful lot of stock in, very simply, Tammy's idea was that we should connect that point to that point. Now, is that, who said the phrase best fit line earlier? Thank you, Francis. Is that the best fit line? I hear a yes and I hear a no. And I hear an awful lot of quiet.
Well, I guess wouldn't the best fit line be where it has to fit through half of each? I mean, it has...
Hold that thought. May I erase some of this stuff up here? Is it okay if I take this away real quick? Real quick? Okay, real quick. When I say real quick, it's not coming back. So if you're taking notes, that's very, very good. I guess we have it on the video if you want to watch that. So, Tammy, no disrespect to your line, but I want to mention something about this line. Remember I mentioned how, although it hits perfectly this point and that point, it misses on the other 3. It misses on the other 3. Can you make a line that misses less? Can you make a line that misses less? So I'm gonna clear the board and have you take some ideas. So there's, actually I'm not gonna clear the board, I'm gonna leave Tammy's up there. Can we make a line that misses the points on average? I'll use the word on average. Because very easily you could have, well, I'm gonna leave it to you. Pick some other points or pick some other line that you think would do a better job than Tammy's of fitting. And when I'm defining better here, I'm defining better as it misses less, which means these little residual lines, these guys are called residuals, are on average smaller.
268.
Say that again.
268.
2, 6. Are they collinear?
I feel like
They're not. Damn, they're not. Check it out though. Check it out. Because 2 to 6, that's a change of 4, yes? And that's a rise of 4. So that's a 1-to-1 slope. And then 6 to 8. I heard 6 to 10. 2, 6, 8. Love it, love it. Sorry about that. I was going 2, 6, 10. 2, 6, 8. Oh, boom, boom. Let's use a different color. Let's use orange. Or yellow. Sorry about that. There. How about that? So now what we have is we do not miss with the reds at all because it caught those. We pick up this one, but then we've got this here, which is actually bigger than that residual overall, and we've got this deal here. It looks visually though like it misses less, yes?
Yeah.
Would that one have a different slope? Would that one have a different slope than the previous one?
Yeah.
Tell me how it would compare. Don't call this one out. It would have a different slope. It's tilted differently. Tell me how it would compare to the first one. Don't call it out. Think about it. Would it be greater or less? Don't call it out. Think about it. Would it be greater or less than the previous one's slope? So Tammy's slope was 9/8. 9 million people over 8 years. Would this one here, we've already answered the question inadvertently when I was looking at the wrong points. Would this one have a greater or lesser slope than the previous? Let me see hands now. Greater or lesser slope? Who's got a vote for me? Greater or lesser slope? Tell me your name in the back again. Michelle, go for it, my friend. Oh, you were just agreeing. I'm sorry. I'm like an amphibian. I see motion. Please, Randall. It's got to be less, yes? It's tilted down. It's tilted down. I mean, if you think about it, positive slopes, the more they tilt up, the larger the slope, larger the grade. Remember the steeper streets, more grade. So this one lays down. This is like College Way versus my driveway. Yeah, well, maybe my driveway was that steep. Actually, nothing's this steep. It's a 1-to-1 slope. The slope actually is on this line 100%. It's a slope of 1. Because for every 2 years, you pick up 2 million, according to this model. Okay? So, lesser slope. Here's a question. How would the y-intercept change compared to the previous line? This is the last time I'll mention anything analytical about a y-intercept. This is the last time I'll mention anything analytical about it, because honestly, the y-intercept isn't as crucial as the slope. The slope is way more important. But how would the y-intercept change? It would have to go up higher, wouldn't it? If you're basically, they're both going through this point, correct? So if you've taken this green line, watch my arm, and you pivot it down around that point to catch this line, this end of it is going to have to come up to match that pivot. Is that fair? Now, can anybody think of a reason why I'm going to stop analyzing the y-intercept so much? Because it sucks, that's a good reason. Because it sucks. Anybody a mathematical reason why? I can't speak to the mathematicalness of suckage of y-intercept.
How often do you use 0, like the zoo?
Can I augment that question, Brittany? It's kind of arbitrary how you define 0. Suppose, for example, I call 0 1900 versus 1990. Right? Suppose I call 0 1900 versus 1990. These lines are going to have the exact same slope. They still tilt the same. They still pick up 9 million over 8 years. Or 4 million over 4 years. They have the exact same tilt. The slope is consistent. But the y-intercept is going to change because it's going to have to go further back to catch it. And sometimes those y-intercepts are going to end up being negative, things that are dumb. Like in 1900, you're going to have like negative 8,000 uninsured people. That's stupid. You can't have negative uninsured people. So I tend not to focus on y-intercepts because of that somewhat arbitrariness. In that way, it does suck a little bit. So I like to focus on the slopes because the slopes stay consistent. Good. Can anybody beat, one more time your name?
Ian.
Ian, thank you. Anybody beat Ian's line? Can we beat that line? Get a little less residual? Any votes?